How did ancient civilizations, without steel cranes, hydraulic machines, lasers, electricity, or digital design construct structures so enormous, so precise, and so enduring that they still challenge our understanding today? Imagine pyramids that rose higher than any building on Earth for thousands of years. Temples carved into living mountains with the accuracy of modern tools. And stones so massive that even today's heavy machinery strains under their weight. But somehow, against every limitation of their age, humanity's earliest builders accomplished feats that still feel nearly impossible. This is the story of how they did it. A story of ingenuity, obsession, cosmic knowledge, and engineering brilliance so advanced that modern experts still debate how it was achieved. Let us return to a world where invention was born from necessity, where mathematics was sacred, and where architecture was a bridge between earth and sky. A world where the human hand, guided by vision, ritual, and problem-solving, shaped monuments that would stand for millennia. Our journey begins in the Nile Valley. Over 4,000 years ago, in the desert heat rises a structure so vast, so mathematically perfect, that even today it dominates the landscape. The Great Pyramid of Giza, built during the reign of Pharaoh Khufu. This megastructure once stood taller than any human building in existence. Its gleaming limestone casing, reflecting the sun like a giant star fallen to earth. For centuries, people have speculated, how could a Bronze Age civilization move millions of limestone blocks, each weighing 2 to 3 tons, into perfect alignment, without wheels, without iron tools, without precision surveying instruments? The answer lies in one of humanity's earliest engineering revolutions, the mastery of logistics. Egyptian builders organized labor like no civilization before them. Thousands of skilled workers, supported by entire towns built for this purpose, worked in teams, each group responsible for quarrying, cutting, hauling, lifting, or aligning stones. Water channels were dug to reduce friction on sleds. Mud and water were poured onto desert sand to create a slick surface for hauling. And ingenious lever systems, simple but powerful, gave workers mechanical advantage that multiplied their strength. The pyramid's base was leveled to within less than an inch across an area large enough to hold several city blocks. Its sides align almost perfectly to the cardinal directions, and its internal chambers demonstrate careful planning, stress distribution engineering, and an intuitive understanding of physics centuries before Archimedes or Euclid formalized the rules. The Great Pyramid is not just a symbol of power, it's an engineering document in stone. But Egypt was not alone. Across the sea, another civilization carved a megastructure so audacious that it remains one of the greatest feats of rock engineering ever attempted. High in the cliffs of Petra, the Nabateans carved entire buildings, temples, and tombs directly out of solid sandstone. The treasury, Petra's most iconic monument, appears as if a massive Greek temple has been pressed into the mountainside. Columns, statues, staircases, and all, yet it is carved from one continuous piece of stone. One miscalculation, and the facade would collapse before it was finished. But the Nabateans executed their designs with astonishing symmetry, geometry, and structural control. They used plumb lines made from plant fibers, measuring rods marked with charcoal, and stone hammers sharpened in desert fires. They were part engineers, part sculptors, part astronomers. Their water engineering was even more miraculous. Living in one of the driest regions on Earth, the Nabateans carved channels into mountainsides precisely sloped to carry water without losing speed. They built ceramic pipes, waterproof reservoirs, and underground cisterns. They even created pressure systems capable of delivering drinking water into the heart of their desert capital. Petra was an oasis built by human hands, powered by innovation. But engineering genius did not belong only to the desert kingdoms. Far across the Mediterranean, a different kind of megastructure rose, floating not on rock, but on water. Around 500 BCE, the Greeks constructed the Temple of Artemis at Ephesus, one of the 7 wonders of the ancient world. This colossal building stood atop a swampy plain. Many thought construction there was impossible. How could a building of marble, weighing hundreds of thousands of tons, stand on soft, shifting Earth. But the engineers of Ephesus solved the problem through a technique that would reappear thousands of years later in places like Venice. Foundation damping. The swampy ground acted as a natural shock absorber. Earthquakes that destroyed other Greek cities passed through Ephesus with less damage because the flexible base absorbed seismic waves. The architects embedded layers of charcoal and animal hide beneath the foundation to further stabilize the weight. The result was an architectural marvel that combined geological insight with structural engineering far ahead of its time. Yet even these achievements pale beside the engineering achievements in the heart of the Andes, the Inca Empire, stretching thousands of kilometers along the world's longest mountain range, created structures so masterfully built that not even earthquakes could destroy them. Machu Picchu is perhaps the most famous example, perched like a stone crown, high above the clouds. But its beauty is matched only by its engineering. The Incas carved terraces into impossibly steep mountains, which captured water, prevented erosion, and created farmland capable of feeding entire communities. Their stonework, especially the massive blocks of Sacsayhuaman, fits together so precisely that a sheet of paper cannot slide between them. These stones, some weighing more than 100 tons, were shaped using hammerstones and abrasion, then dragged with rope down mountainsides. But the real brilliance lies in their anti-seismic design. The walls tilt inward, their stones interlock like puzzle pieces, and the entire structure flexes during earthquakes. Instead of collapsing, Inca buildings absorb vibrations and settle back into place. But no story of ancient megastructures is complete without traveling to a land where architecture was both art and cosmic devotion: India. At the Ellora Caves, Indian craftsmen carved an entire freestanding temple, the Kailasa Temple, out of a single mountain. Unlike Petra, which carved facades shallowly into cliffs, the Kailasa Temple was excavated from the top down. Imagine starting with a solid mountain and removing over 200,000 tons of rock by hand while keeping the structure's pillars, ceilings, stairways, and sculptures intact. The architects had to visualize the entire structure in 3 dimensions before touching a single tool to stone. They had to calculate load-bearing distribution as they carved deeper. They had to ensure that columns didn't crack, beams didn't buckle, and walls didn't collapse. This was planning and execution of unimaginable precision. Modern architects call it one of the most difficult architectural tasks ever attempted. Yet it was completed over 1,000 years ago, with nothing but chisels, hammers, geometry, and devotion. Travel further east, and you reach Angkor Wat, the largest religious structure ever built, a megastructure that required millions of tons of sandstone to be transported across dense jungle without wheels. Khmer engineers built canals, rafts, and complex barge systems to move stone across water. They constructed an entire city with astronomical alignment, its central tower representing Mount Meru, its layout designed to mirror the cosmos. Its foundations were built on layers of sand, carefully compacted and reinforced, acting as natural dampers against monsoon rains and ground movement. The Khmer were not just building temples, they were building a model of the universe. Now journey across the Pacific to the ancient Americas, long before recorded history. On Rapa Nui, better known as Easter Island, the Rapa Nui people carved massive stone statues, the Moyich weighing as much as 80 tons. They transported these giants across the island without wheels, without large animals, without metal tools. Their method, a walking technique. By carefully rocking the statue left and right, they made the Moai walk forward like a refrigerator being moved across the floor. It required coordination, rhythm, and deep knowledge of balance and friction. Their engineering mastery transformed volcanic rock into living monuments. And then, there is the lost city of Teotihuacan in Mexico, a city so vast that its builders remain anonymous. The Pyramid of the Sun is almost as large as the Great Pyramid of Giza. Its construction required cutting millions of tons of volcanic rock, arranging them into a geometrically precise grid, and aligning the entire city to celestial events. The Avenue of the Dead, the central artery of Teotihuacan, aligns with the sunset on specific days of the year. Its architects embedded layers of mica mineral used in electrical insulation beneath certain buildings. Why? We still do not know. But the scale and ambition of Teotihuacan remind us that engineering wisdom was not confined to one region of the world. Even in Europe, long before Rome, ancient builders constructed megalithic structures like Stonehenge. Each stone weighed up to 40 tons and was dragged across land and river. Stonehenge's design aligns with solstices, revealing both engineering and astronomical knowledge. Its builders created mortise and tenon joints carpentry techniques carved into giant stone pillars, allowing the monument to withstand thousands of years of weather. Across all these civilizations, from Egypt to Greece, from India to the Andes, from Angkor to Easter Island, common truth emerges: humanity's earliest builders were not primitive. They studied the movements of stars. They understood load, distribution, friction, leverage, and earth pressure. They solved problems through experimentation, through tradition, through trial and error, passed down across generations. Their tools were simple, but their minds were extraordinary. So how did they build megastructures? They organized labor with the precision of modern companies. They mastered geometry, astronomy, stonecraft, and hydraulics. They thought in centuries, not years. Every civilization had its own methods, its own secrets. Yet they all shared the same drive, to leave behind something that would outlast time. Today, cranes can lift hundreds of tons. Computers can simulate stresses and loads. Satellites can map landscapes. But there remains something awe-inspiring about the idea that long before any of these tools existed, human beings, using only their hands, their minds, and their wills shaped the planet with megastructures that still stand. We often ask, how did they do it? But perhaps the better question is, what drove them to try? Was it religion, power, astronomy, a desire to connect with the heavens? Maybe it was all of these. Or maybe, deep within humanity, there has always been a spark of desire to build something greater than ourselves. As we walk among these ancient giants, pyramids, temples, monoliths, fortresses, we are reminded of the one truth that echoes across all civilizations. Human potential is infinite. Our ancestors proved it, and their monuments still whisper the same message today. If they could build the impossible, then so can we.
What do you think? Share your thoughts in the comments, and don't forget to like and subscribe for more.